Good afternoon, everyone.
Hey, good afternoon.
I, Shashank, on behalf of NEN and Vajani Foundation, would like to invite you all for this webinar and also introduce our expert. Mr. Varoon Rajani is the founder and president of cloud consulting BlazeClan Technologies, a young and fast-growing cloud consulting company based in Pune. At BlazeClan, Varoon is responsible for cloud computing consulting and overall growth of the company. Before founding BlazeClan, he has worked with Infosys Technologies and Tata Consultancy Services. He has worked extensively with enterprise applications and enterprise resource planning solutions. Varoon is a cloud enthusiast and is always eager to innovate and explore new technology solutions to achieve greater cloud infrastructure efficiency. He is a voracious reader on technology and regularly blogs about his thoughts around the same. Before I hand over the floor to Varoon, here are a few reminders for the audience. You will all be on mute. You may ask a question by typing in the panel provided. Over to you, Varoon.
Thank you, Shashank. Good afternoon, everyone. As Shashank is here, and I look after the cloud consulting services. Before we start, a request to all of you: if you have any feedback, please post it on Twitter. Tweet it on Twitter using the hashtag NEN Webinar, and you can reply to your tweets at NEN India. I'll start with the webinar now. The subject for the webinar for today is cloud computing for startups. Before we start on the actual topic, I'll just explain what is cloud computing in a brief. Whenever you ask about cloud computing to different people, you'll get different definitions of it. Right? Here I've tried to put in certain definitions which we receive when we talk to different people. It could be computers for rent on the internet, it is virtualized servers, some may call it storage in the sky, free email service, etc. So what is cloud computing after all? There is no one correct answer. All answers are correct partially, and all of these make up cloud computing in general. Here are certain definitions from various leading publications as well as Wikipedia. So Gartner defines cloud computing as a style of computing where massively scalable IT-related capabilities are provided as a service across the internet to multiple external customers. Forrester, again a leading research organization, defines cloud computing as a pool of abstracted, highly scalable and managed infrastructure capable of hosting end customer applications and built by consumption. Finally, Wikipedia defines cloud computing as the use of computing resources, both hardware and software, that are delivered as a service over a network, typically the internet. So as you might have, as you can see, all the points highlighted in orange, cloud computing is basically consuming computing resources. It could be hardware or it could be software as a service. As a service would mean that we do not buy or purchase any computing power, we do not buy or purchase any licensing. Rather, we would use the hardware and software resources as a service, and at the end of the month, we will pay for the amount of usage or amount of consumption of those resources to the provider. So to start with, I'll give you an analogy between electricity and cloud computing. Right? So we are saying cloud computing is basically consumed as computing power consumed as a service. So you could think of it as electricity. Right? You can draw a parallel between electricity and cloud computing. When we want to use electricity, we do not go and implement our own generators or our own thermal power stations or anything. We simply would connect the local or the government electricity provider, and we get a connection and we start using it by just flipping on a switch. Similarly, computation power is now available like electricity. You don't have to build your servers, or you don't have to buy servers. You do not have to buy any data center space. You may even not have to buy any kind of software licensing for a lot of software that are available on the cloud. Secondly, you can pay for what you use. So, just like electricity, for electricity you get a bill at the end of the month, which would give you the amount of units consumed by you, which would give you the unit price for a specific electric unit, and then they add on the charges for taxation, etc., and give you the final total, which you pay to your electricity provider. Similarly, for cloud computing in its traditional term would mean that you use your computational resources, and at the end of the month you get a bill which will consolidate all the uses that you have done from a particular provider, and then you pay the bill. So you do not invest any capital expenditure into it. And finally, you rely on a trusted third-party provider who actually has an experience of delivering computational services to a lot of people, millions of people across the globe. And you are working with the experts. You get the best of the service from experts. So basically, cloud computing is computational power on demand, on a pay-as-you-go basis, and it's uniformly available just like electricity, and it's available all the time. There are three different cloud computing layers, or three different ways on how you can consume cloud computing. The first one is software as a service, second one is platform as a service, and third one is infrastructure as a service. We'll start with software as a service. What do you mean by software as a service? I'm sure everybody here uses some kind of software as a service, for example, Dropbox, or for example, Gmail, right? All of these are services that you use, computational services that you use, and for some of those services you probably pay at the end of the month. For example, if you use Google Apps for enterprise as a startup, you probably pay a $5 fee per user per month at the end of every month for all the users that are there in that are registered with Google Apps, enterprise apps for your organization. So software as a service would basically be applications that you consume or the data that you consume. Popular software as a service applications which are available today in the market are Google Apps, which provides a suite of email services, collaboration services with Google Docs, and a lot of other services. The most popular software as a service enterprise tool today available is Salesforce.com, which is an enterprise CRM application. One level below software as a service, we have something called as platform as a service, wherein you get computing platform or a solution stack as a service. So for example, if you are a startup trying to build a software on say LAMP stack, right? Then you have to initially when you buy certain computational power or a server, you'll have to deploy that stack and then deploy your code on top of that application stack. Rather, with platform as a service, what you can basically do is you get all these components of your stack pre-built on the platform. For example, you have an inbuilt or a pre-built database, which would be a managed database. You get operating system already loaded onto your solution stack, and you get runtime environments for different application programming languages. So the infrastructure part, the management of infrastructure is totally gone away from the developer and is now managed by a cloud provider. Popular platform as a service and the companies include Force.com, which is an extension for Salesforce.com, and you have Google App Engine. So you can with Google App Engine you can build your own applications in multiple languages using a lot of different programming languages and databases supported by Google App Engine. Finally, the bottommost layer of cloud computing is infrastructure as a service. Infrastructure as a service would mean a virtualized IT infrastructure available as a service. with infrastructure as a service, you basically can launch any number of virtualized servers over the internet. You also can have a lot of storage. There are a lot of storage services available in infrastructure as a service, and you could also have a lot of networking services available as infrastructure as a service. The two most popular IaaS providers today are Amazon Web Services, which is the market leader in IaaS space, followed by Rackspace, which is a distant second here. So with infrastructure as a service, you could virtually launch supercomputers in a matter of few hours or a few minutes rather. So these are the basic layers of cloud computing. Next, I'll discuss about 5 reasons for startups and SMEs to use cloud computing. I'm sure there are more than 5 reasons, but I'll just try to talk about the top 5 reasons here. The first reason that any startup should use cloud computing is that it has no capital expenditure, and it is available as a pay-as-you-go service. Like the analogy which I mentioned earlier with electricity, the moment I shift into a new house or a new office, I do not install a generator, I do not install a power plant on my premises. I would rather have a connection from the electricity provider and start using it and pay for my usage at the end of every month. Similarly, for cloud computing, I do not have to pay for any kind of I do not have to spend any kind of capital expenditure. Rather, I would just sign up for a cloud service, use the computational power that I require, and at the end of the month, I would receive a bill which I would pay to the cloud provider. So the advantage here is I'm not investing in data center resources, I'm not investing in any kind of servers, I'm not investing in any kind of licensing. So this is the first advantage why a startup should be using cloud computing. An example that I wanted to share with you for a pay-as-you-go mode is Netflix.com. I'm sure everybody is aware of Netflix.com. Netflix.com is an on-demand internet streaming media with revenues of 3.2 billion. Again, it's not a startup in its traditional terms, but it started small. And it controls over 66% of the digital movie rental market in the US. Sometimes the traffic peaks on weeknights and weekends, and it accounts for 33% of internet traffic during peak periods. Why I am giving you an example of Netflix is because even though it controls, or even though it has a 33% share of total internet traffic in the United States, it runs all its applications and it streams all its movies and its TV programming shows using Amazon Web Services Cloud. It does not involve any, it does not have any of its own data centers, it does not own any of its servers. Everything is rented out from Amazon Web Services, which is again a leading cloud computing provider. So as a startup, you can imagine how you could basically launch an application which is immensely scalable as Netflix, without even investing a single rupee into the infrastructure required to sustain your business. The next major advantage of cloud computing is the elastic capacity. Now, what is elastic capacity? Elastic capacity for computing would mean that I could add servers, or I could remove servers which are hosting my application as and when I want it. So, for example, if you are an e-commerce application, or if you run an e-commerce startup, your typical traffic would probably come during the daytime, which would be say 8 AM till 10 PM in the night. But between 10 PM and 8 AM the next day, the traffic to your website is not very heavy. But if you are already invested into a data center, you'll have, for example, 10 servers running 24/7 to support that infrastructure of your e-commerce platform. But if you move to cloud, your capacity of computational power could increase in an elastic manner, which would mean the moment my traffic or the moment the traffic to my application increases, you can add computational power in an automated way. So for example, between 8 a.m. and 10 p.m. during the day, I could have 10 servers running, and if I get major traffic or increase in traffic, I could add the 11, 12, 13, 14, 15, any number of servers automatically without any human intervention. And during the night time, when the traffic falls after 10 p.m., the number of servers could reduce from 10 to, for example, 3, which is the minimum number of servers I would require to sustain my or to keep my web application online. So this is how you can use elastic capacity of cloud computing to ensure that you can handle any amount of loads that you get, and you can increase the computational power required to support that load, and you could even decrease the computational power once that load or once that peak has gone down. An example for this elasticity would be the company called Dropbox.com. I'm sure everybody has heard about Dropbox.com, and everybody has Dropbox.com application installed on your computers and on your laptops. Dropbox.com runs on Amazon Web Services, again the leading cloud computing provider. And Dropbox.com uses Amazon's simple storage service, or Amazon S3, for storing files. Just imagine Dropbox.com was launched in January of 2010, and since then till December 2012, that is last year, they were saving 1 billion plus files every 24 hours, and it stores more than 40 petabytes of data. Now that is some scale to achieve. 40 petabytes of data generated and supported by Dropbox.com in the first 3 years of its existence. So that is elasticity. Dropbox.com does not have any storage infrastructure of its own. It uses Amazon Web Services Cloud to store all the files which you and I would store on Dropbox, right? So that is the power of cloud computing. The third major factor that you should consider for using cloud computing, it is all self-service. It is all API driven. What do I mean by self-service, or what do I mean by API driven? So as an example which I said earlier, for your e-commerce application, if you are using, if you get an increase in the number of users to your e-commerce website, you could increase the number of servers which support, which host your e-commerce application. And you can do it all automatically. You do not have to actually go down and start the servers or stop the servers on your own. Everything is self-service, everything is API driven, and you do not need any infrastructure expert to help you out with this. You could basically be a non-IT person with basic understanding of internet, basic understanding of how to use a web application, and then you can yourself launch servers, yourself stop servers with very basic knowledge of IT, or very basic knowledge of cloud computing. So that's how easy it is. Previously, in the traditional way, you would, if you want to launch an application, you will first have to buy hardware from somebody who sells the hardware. Then you will have to get a computer guy or a system admin guy who will come and set up the server. Then you will have to get a network guy who will set up the network cabling and will ensure that your server is now connected to the internet. Then you will have to have the software developer and who will deploy the application and then you can start using your application. But with cloud computing, everything can be done by one single person who has basic understanding of computing, and he or she can launch any number of servers, any number of databases. He or she can establish networks, can make your website online in a span of a few minutes. So that is again very important when as a startup you want to keep your costs down, as a startup, when you do not have access to expensive system admin resources or network admin resources, all you need is basic understanding of internet and you can start using cloud computing. The next major point why you should be using cloud computing is automation. Automation would mean that if you can automate a lot of processes that you use on a lot of processes that you would use to sustain your application or to support your application. You automate them, and those things will be taken care by the code or by the setup that you do. For example, startup, if you are into technology space, you would deploy your application first on a development environment, then you would deploy the same application onto a test environment, and then finally once it is tested, you will deploy it onto a production environment. In traditional cycle, you would ideally set up the development environment first, you would do the deployments, do your development. Next, when the hardware, different operating system, deployment of applications, and finally deploying production. Now, just in, if you an internet scale startup with thousands and millions of users, this but with cloud computing, you can easily automate everything, and things could be done automatically. So that is power of automation. Here I would like to share with you an interesting example of Pinterest.com. Pinterest.com is again a social networking site, a very popular social networking site, which has had the most number of users in the shortest possible time. Right? So if you see the statistics, it had 17 million unique visitors in a month in a span of 9 months since its launch. If you compare that with Facebook, Facebook reached the number of 17 million in 16 months. What does Pinterest do? Pinterest does not have any infrastructure of its own. Rather, again, it has 150 virtual servers on the cloud. It has 70 master nodes and 70 slave nodes for its database, which anybody with basic understanding of database would say is huge amount of huge numbers of nodes that it has, total of 140 nodes, and it stores 8 billion objects totaling up to 410 terabytes of data. Now just imagine a startup with 0 users in the first month grows up to 17 million users in a span of just 9 months, and it supports 150 virtual servers for its application, 140 nodes for its database, and it has just 12 employees. Just 12 employees. And out of these 12 employees, I'm sure there would be programmers, I'm sure there would be marketing guys, I'm sure there would be sales people, and there would be people who would be actually supporting this infrastructure. Right? All of these, total of around 300 nodes on 300 nodes, including their application and database servers, supported by just a team of 12 people, supporting 17 million users in a short span of 9 months. That is the power of cloud computing. Finally, and the most important point of cloud computing on why as a startup you should be using cloud computing is focus. As I said, Pinterest, for example, had just 12 users or 12 employees working on their applications supporting 17 million people. Just imagine if they had to reach this scale with 12 people without using cloud computing. I'll tell you, it is almost impossible to do it. Reason? Because if you have a traditional hardware infrastructure or a traditional data center, you first of all will need more than one system admin to look at 150 virtual servers. You'll have to have a couple of networking guys who will ensure that the internet connectivity or the internet bandwidth going out of your data center is is good enough for people to view your application without latencies. All of these things will take a larger team, and it would take away the founders' focus away from building a world-class application to rather supporting the number of users that are increasing day by day. And mind you, if you are not able to support your existing users in a satisfactory manner, you will not get any new users going forward to your application. So it is very much important to ensure that you maintain the balance between your application development and supporting infrastructure for your existing and your new users. Cloud computing allows you to focus on the application that you are developing, the dream, the idea that you have, and allow you to just have limited focus on the infrastructure because it is all automatically taken care of, right? So you do what you on your idea, develop on your application, and leave alone the maintenance of your infrastructure to cloud computing providers. So that is the end of what I had to share, the 5 reasons, as I said. The number 1, pay as you go. Number 2, elastic capacity. Number 3, automation. Number 4, self-service. And number 5, focus on what you do the best. So with this, I would like to end my presentation, and I would be happy to take questions from all of you. In case if you have any other queries, you could drop me an email at varoon@blazeclan.com, or you could visit our website blazeclan.com, and you can fill up the contact us form, and one of my team members will get back in touch with you. I am open for questions.
Okay. Thank you, Varoon. We'll begin with the question answer round now. The first question is from Mr. Hafiz. He says he has a mobile startup and he's working on his first product. The product enables the user to save news and other important links. They have both database and application services. Well, his question now is that which cloud service should be selected for the same, and where should he focus exactly on?
All right. Mr. Hafiz, there are a lot of different cloud computing vendors which are available in the market today, and you can select any one of them. And the most popular and the market leader in the infrastructure as a service space today is Amazon Web Services. Amazon Web Services provides you with managed databases. It provides you with virtualized servers, supporting multiple different operating systems like Linux, like Windows, etc., all on a pay-as-you-go basis with licenses included. Having said that, the other options that you could be using is Microsoft Azure, which is again a very good platform, but with limited features when compared to AWS. Microsoft Azure also provides you with managed databases and virtualized servers with both Linux and Windows operating system. We ourselves run a few products, and we have customers who have their mobile applications, and our recommendation always is to go with Amazon Web Services. But without being biased, Microsoft Azure is also a good option. But my suggestion and my recommendation is always AWS because of the features it provides and because of the extensive support that it has, and even for developing mobile applications and mobile SDKs. I hope I've been able to answer your question.
The next one is from Mr. Shankaran. He asks,
okay,
could you please tell the uses of cloud computing for small and medium scale businesses? Like, for example, mainly he wants to know for non-tech startups.
For non-technology startups?
Yes.
Okay. So, Mr. Sankaran, I'm sure even if you are a non-technology startup, you would have requirements of using, for example, email service or some kind of ERP application or some kind of a CRM application, right? So, if you are a non-technology startup, I would suggest that you do not worry about the infrastructure as a service or platform as a service layer of cloud computing. Rather, you could readily use a lot of software as a service applications which would help you in streamlining your business processes in a much quicker and faster way. So for example, you could use Google Ads for your email services, which is again software as a service available on cloud. Uh, Google Ads gives you, I think, 5 to 10 users for free for lifetime. But beyond those numbers, you need to pay a fee of, I guess, rupees 150. You can again cross-check it on the Google Apps website. You can pay a fee of rupees 150 per user per month and start using those services. You could also sign up for a lot of CRM applications, a lot of ERP applications which are available as software as a service. One of the examples that I gave was Salesforce.com. But apart from Salesforce.com, there are a lot of cheaper options available for startups and SMEs, to help them streamline your internal processes like ERP, like billing, invoicing, CRM, etc. Yeah, I mean, if you have any specific kind of application that you want to use, you can let me know, and I can help you with the possible alternatives available on cloud for your requirement.
Manish has the next question
Mr. Shankar.
coming up for you. He asks, how can I select a cloud storage facility ready to scale up but not overspending in the initial days for huge spaces?
Okay, what was the, I mean, who did, from whom was this question from? I missed out on the name.
Yeah, Manish.
Manish. Manish, on cloud, there are 3 types of storage services that are available. Basically, with almost all the cloud computing vendors will have these 3 types of storage services. One is an object store, the other is a block store, and the third one is your traditional database stores, right? Now, depending on the type of usage that you are looking for, you could select one of these storage services, right? So, for example, if you want to store objects, which would include, say, your picture files, media files, video, audio, radio, any files that you want to store directly, you could use an object store. Dropbox uses the simple storage service from Amazon, which is an object store. You could actually store it and you will get a URL for to access that object. So anybody on the internet can access the object using a URL, as simple as that. So definitely there would be different types of security mechanisms to ensure that not everybody has the access. But idea is that you could store an object and you can get a URL to access that object. That is called an object store. An example of an object store, as I said, is Amazon Simple Storage Service. So if object store is your requirement, then you can use something like Amazon S3. The next one is a block store. A block store is basically a type of storage wherein you get a fixed block of memory, and then you can store anything on it. You can store objects, you can store databases, you can store your application. So block stores are typically attached to virtual machines on the cloud, and you can install or implement or store anything that you want. It's basically like your hard disk attached to your computer. Right? So you will always have to have some application accessing the data which is stored on block store. And third one, of course, is the database which you actually use to store the data. Right? These databases, there are a lot of databases which are available as a service in the form of managed services for you, right? So you sign up
Mr. Varoon, your voice is not audible enough. It is breaking up.
is it Okay, now?
Not yet.
Okay. Hello?
Yeah, now it's perfect.
Okay. All right. Okay. So I'm sorry, I'm not sure till where you able to hear me clearly.
Okay. I lost it 30 seconds ago.
All right. So, okay. So I explained first of all object stores. Secondly, block stores. Block store, as I mentioned, is a storage type which you can attach to your virtual machines which you use on cloud, and it has always to be accessed using some kind of an application, and you cannot directly access it, or an end user cannot directly access it using a URL or something like we can do in an object store. And so that is block storage for you. And finally, the third type of storage that you can use on cloud is a managed database service. A managed database service would give you a database which is fully managed, which would mean that you do not have to worry about taking backups of the database. You do not have to worry about setting up, master and slave nodes for your database. You do not have to worry about the database going down or replication of the database. All of that could be automated. So one leading example of a managed database services is Amazon RDS, or Amazon Relational Database Service, where you can launch either a MySQL or a SQL server or an Oracle database as a service in less than a few minutes, and it is fully managed. So these are the three types of services, storage services that you could use depending on your exact requirements.
Abhishek Barari says that he has an app as well as a browser-based publishing platform. Can he use the Google App Engine for the application and the Amazon AWS for the website, since the website will be handling the uploading aspects?
So Abhishek, I'll have to understand your technology stack in further details, but what you mentioned, and if Google App Engine has the it has the technology stack, or if Google App Engine supports the technology stack that you are using, I'm sure you can use Google App Engine for both the purposes, both to host your website as well as both to upload the data that you want. And you could also use a mix of both Google App Engine and Amazon Web Services, right? So it would depend on your use cases, on the your exact requirements. I would be happy to guide you once I have more details about your application, right? I mean, but yes, it is possible to use both of them for your application, but the recommendation will only come after understanding more about it.
Raveen
Send me a
Pandey.
note to my email ID. Sorry.
Raveen Pandey has the next question for you. For a SaaS cloud in education domain project, which one is the best cloud application? And can you please throw some light on IBM's SCE Plus for managed applications, or is there another alternative?
What was the last part? I got the first part which says what is the best software as a service application for e-learning.
Yes.
Uh,
He wants to know more
and
about
second,
IBM's SCE for managed application, or is there another alternative for the same?
all right. So Praveen, interestingly, we also, as a part of BlazeClan, have our own platform, which is again an e-learning software as a service platform called briskgap.com, right? briskgap.com. So we provide a technology platform for e-learning companies or for educational institutes to upload their own content, to enroll their own students, and then run a course internally or externally. If you are talking about software as a service along with content, then there are a lot of alternatives like Classlay, which is again an Indian vendor. Then there is something called as goals.in, which again has a lot of content available as a service. And you have lynda.com, lynda.com, which is again a software as a service available for e-learning. And then you have a lot of MOOCs platform available for viewing e-learning content. So again, it is very specific to the domain. There would be software as a service applications identifying or helping you with certain type of content, certain domain of content. Or you could go ahead, if you want to have your own, then you could use a platform like BlazeClan, as I mentioned. Right? About the second question, IBM's SCE, I am not aware much about it, but there are alternatives to SCE as well. Again, it would depend on your specific use case, what kind of technology stack that you are using. We can discuss it offline, and I could help you and guide you to the alternatives that are available.
Maruti Sriram says that he's running a corporate training solutions company, a startup which is just 3 months old. How can cloud computing help him for this specific business model?
Alright, so is your, Shashank, can I ask a question and get a response from the person who has asked the question?
He'll have to type it out in the panel here. So please answer based on what you got from the question.
Okay. My first question would be whether his startup is an online startup or an offline startup. When you say learning domain, you could have a classroom and people sitting in a classroom and you teaching them, right? So or you could have an e-learning platform, which was in continuation with the previous question. You could have an e-learning platform wherein you are teaching multiple number of students sitting at a single location.
Okay.
Sitting from a single location.
Varun?
Whether it is an online or an offline startup.
He says it's offline as of now, but wants to go for an online setup in the coming days.
Right. So the answer for you would be you can have your own setup done. You can have your own platform created or built on top of cloud, wherein you can upload your content and you can sell courses online, for example, at a subscription fee or at a one-time fee to the end user. You could also take advantage of tools like online classes, which will help you to connect to multiple users at the same time, and you can interact with them just like you do in your classroom, but all over the internet. So yes, these are the things that you could do. For this, you can set up your own infrastructure, or you can use a platform like BlazeClan.com, which would help you in extending your classroom to the internet. And it could give you a wider audience. So for example, if you are sitting in a particular city and teaching a group of 50 students, with the reach over the internet using cloud, you could essentially reach out to the whole world and get more traction if you market it correctly.
Navi Arora has
yes,
the next question.
Probably we can take the next question.
Yes. She says she's administrating her own Debian-based VPS at Linode to host a Magneto-based e-commerce venture and a few WordPress blogs. She optimized the server in the best possible way with time backups, firewalls, and engines. How can cloud computing benefit her?
Alright, so as I understand, you are using Linode, which provides you a virtual private server. But as far as I have the knowledge, VPS are not scalable. So for example, you mentioned a Magento-based e-commerce platform and a few WordPress blogs. So if your e-commerce application is a hit overnight, right? Or for example, you suddenly see an increase in the number of users that you get on your website or your e-commerce platform. the lead node application may fail, and it may crash or it may go down. But with cloud computing, you can basically insure yourself against such kind of a damage by having auto scaling done, which would mean that you could scale up your computing resources or scale down your computing resources based on the number of users or based on the traffic that you have on your website, and all of this could be done automatically. So and also sometimes, not always, but sometimes it is much more cost efficient to use cloud rather than using a service like Linux. Plus, it's much more secure because you get various options like setting up your own firewalls, setting up your own virtual private cloud over a public cloud to ensure that the safety and security of your application is maintained, which may or may not be the case with hosting provider, because it's everything is shared with multiple users, multiple companies.
The next question is from Krishna Chaitanya. He asks, how many concurrent users can cloud-based servers handle at a point of time?
The ideal answer is infinite. Basically, you can have any number of users, attached or accessing your applications concurrently. That would, if the application is A, architected correctly, and B, if you're using a scalable, and if your application itself is scalable. So, for example, a software as a service has like Google App Engine, right? It supports millions of users every day, all concurrently logged in. So basically, infinite. We cannot put an upper limit to it. Just that your application code has to be scalable, and the infrastructure architecture on cloud that we use has to be scalable. And believe me, there are ways to do it. You can see the examples that I had provided. Pinterest, which would have a few 100,000 users logged in anytime. Netflix, which has a few million users logged in streaming videos, which is heavy content. Over the weekends in the US, you see Dropbox.com. It gets more than 1 billion files uploaded every 24 hours. If you just divide 1 billion by 24 hours, you could basically mean few lakhs of files uploaded every second. Right? So concurrency is basically infinite, just that you have to architect your application and your infrastructure correctly.
The last question of the day is coming from Miss Pinky. What security measures should she follow when storing thousands of user profiles, accounts and content on cloud? Is an encryption easy to implement?
Is an
encryption easy to implement?
What is it? Injection.
Encryption.
Okay. Encryption. Yes, Pinky, you can do all kinds of encryption using cloud services. So, for example, the 3 storage types that I mentioned earlier all provide you different kinds of encryption services for your data. Right? You can even encrypt and store your files onto S3. You could encrypt the data which is stored on EPS, or you could, even in your database, you could do encryption. Secondly, most of the cloud providers, and you can read the documentation before selecting one, most of them would provide you with encryption services while your data is in transit. Right? So you can even encrypt the data which is in flight from being transferred from point A to point B, and that kind of encryption is also available. The next one is you can set up a lot of firewall like rules on cloud to ensure that nobody can no unauthorized person can access your application or your database, and you could basically have shielded from unauthorized access. So depending on the requirement, there are different ways to encrypt your data, different ways to restrict the access, different ways to ensure that your data is secured and secured on the cloud. Hello.
Yeah. Thank you very much, Varun, for that interesting session. Thank you to all our attendees for participating in the webinar. We are glad that questions kept coming in, but due to a lack of time, we are unable to answer them all. Please do send in your feedback and suggestions to us at eclub@nenglobal.org. Also, if you found the session interesting, feel free to blog or post about it. The recorded version of the webinar will be available at www.youtube.com/user/eclubNEN by tomorrow. Also, join us for our next webinar on how to choose the right co-founder by Mr. Kunal Nandwani, the founder and CEO of UTrade Solutions, on 11th of September at 3 p.m. And for all the audience who have a problem in acquiring customers, NEN workshops are coming right to your city. We have a workshop on getting to market on the 19th of September in Kolkata, 21st of September in Chennai, and in Pune, Bombay, Delhi, Jaipur, and Bangalore on the 28th of October, on 28th of September, on how to acquire customers. Thank you once again and have a nice evening.